Welcome to Brain Vision.
16.70, so we've got the transverse acceleration plotted here for some wave on a string as a function of time at the x equals 0 point on it. And we're told that this has the form of an amplitude times the sine of kx minus omega t plus phi, which I forgot to write the whole point of the problem in here. And then the scale of this is set by 400 meters per second is what a sub s is. So the function that's plotted here, we just set x equal to 0, and now this is the acceleration, so we need to take two derivatives of this. So we're going to get a negative omega out 2 times from just the chain rule, and then we're going to get an additional negative sign from the differentiating the cosine of the speed into the velocity into the sine again of the acceleration. So we end up with a negative sign, and you can work through that out yourself if like a quick little verbal explanation of what we're doing is a little difficult to follow. So x is 0, so then this is just negative omega t plus phi. So now at time 0, this is negative. The slope is negative. I mean, it's also negative, but the slope is what we care about here, which implies if we set t equal to 0 here, that negative sine of phi is less than 0. Oh, I'm sorry. If we look at the slope, of course, we get another cosine and another power of omega, but because we're comparing this with 0, the omega to whatever, the omega cubed and the y sub m will cancel out without changing anything. So negative cosine of phi is less than 0. And so this means we have to have an angle that's either in the second or the third quadrant. So now at time 0, we have negative 100 meters per second squared is our acceleration. This has to equal 400 meters per second squared, the amplitude of the acceleration wave, and this will be times, oh, we have a negative sign here. This will be times the sine of the angle, or the phase, because t is 0, so negative omega t goes away. Negative things cancel. So then we're left with the phase is the arc sine of 1/4. 100 meters per second squared divided by 400 meters per second squared is 1/4. And so this can be either approximately 0.25 radians or 2.9 radians. Now, because we know that this has to be in the second or third quadrant, it can't be this, but it can be 2.9 radians. And also, of course, like any angle, it's equivalent to say that adding any any positive or negative multiple of a whole number multiple of 2 pi will be the same angle because you're just going around a circle a whole number of times. So if you end up with something that's, plus or minus 2 pi some number of times n, then you also have the right answer. Although it's usual to, give angles as positive numbers less than 2 pi. So, which this does, or this is, so it's good.